Gale Banks is an engine builder, engineer, designer, and manufacturer who needs no introduction. But we'll give it our best shot anyway. Gale Banks began reaching engineering milestones more than 60 years ago when at the age of 14 he tore down his mother's 31 Ford Model A engine and managed to increase its power by 65 horsepower. 2 years later, in 1958, Gale was officially in the engine business. Today, he remains the hands-on president of Banks Power, a manufacturing and engineering company that occupies 12 acres in Azusa, California. Banks Power has been at the forefront of designing and manufacturing power-enhancing products for diesel and gas-powered vehicles since the 60s. His engines have continuously broken new ground and have set world records thanks to Gale's engine and engineering prowess, which covers engine architecture, turbocharger design, fuel systems, exhaust systems, ignitions, camshafts, intercooling, and much more. Clearly, he knows his stuff. Something both Gale Banks and our team here at Engine Builder Magazine have been focused on recently are monster truck engines. Gale and his team have been hard at work the past 6 months building a diesel equivalent monster truck engine that delivers horsepower and throttle response as good or better than Monster Jam's current 540 cubic inch big block Chevy blown alcohol engines. The build has been well documented in a series on the Banks Power YouTube channel, but we're going to give you a breakdown of their super turbo 7.1 liter 427 cubic inch Duramax in this episode of Diesel of the Week.
This video is brought to you by AmSoil, the first in synthetics. Visit amsoil.com for more information.
The basic engine in a Monster Jam truck is a 540 cubic inch big block Chevy running an 871 blower. Horsepower in those engines range anywhere from 1,200 to 1,500 horsepower, which is obviously pretty stout. To begin to understand what Gale and his team would need to achieve with a diesel engine, they rigged up the Monster Mutt monster truck with all sorts of Banks Power gadgets to fingerprint the engine while it competed in a typical Monster Jam event. According to Banks, guys have used diesel engines in monster trucks before, but the throttle response is part of the art of driving and operating one of these trucks, and traditionally, turbo diesels are soft. Banks wanted to put a super turbo in one of these, but he wanted it to work right. So what did Banks do? He tested the 540 cubic inch big block Chevy blown alcohol engine on the dyno, so he knew what his diesel engine needed in order to equal those Chevys or kick their ass. According to Gale, engine builds never start with cubic inches or a boost number, rather they start with a power goal. In this case, Gale was looking for 1,400 horsepower. Monster trucks do it at 7,400 RPM. With a diesel, he wouldn't be turning 7,400 RPM to make that number. In order to make that number, Gale needed to know how much manifold air density he had to produce in the intake manifold to flow into the cylinder heads to make the power. He also needed to know what the temperature of the air is. If you want a lot of density, you want cold, dry air. Manifold air density per cubic foot times the engine's pumping CFM is what determines the fuel consumption, and fuel determines horsepower. To begin his diesel monster truck engine journey, Banks used a 427 cubic inch 7.1 liter Duramax engine, which ran a 1071 blower to start. Every component got analyzed to ensure the best performance. Banks ran the blower injecting methanol. He also ran 2 Bosch high-pressure pumps. Running this way, the temperature of the supercharger was over 400 degrees Fahrenheit, so to keep it running cool, Banks added various levels of methanol or water meth. Next, the Banks Power team swapped out the Roots blower for a 5-liter Whipple screw supercharger to see what difference it would make. At only 3,200 RPM, the Roots blower made 12 pounds of boost and 22 pounds of boost air density. The Whipple at the same RPM made 14 pounds of boost and 35 pounds of boost air density. That 13-pound difference on diesel was worth about 100 more horsepower. The Whipple also kept a cooler manifold air temperature, 265 degrees versus 325 degrees. The Whipple delivered higher quality, denser air and picked up more horsepower at the flywheel. With the Supercharger figured out, the Banks team added a Whipple intercooler, which is liquid coupled. Pushing the water through the intercooler are some billet aluminum Stewart Components EMP pumps. Without the intercooler at 3200 RPM, the engine made 235 horsepower with a 23:1 air-fuel ratio and 14 pounds of boost. With the intercooler, the boost was 9 pounds, the air-fuel ratio was 25:1, and the horsepower went up from 235 to 252. The increase in horsepower came from a reduction in parasitic horsepower because the blower was now doing a higher mass flow. When Gale matched the air-fuel ratio at 23:1, the horsepower went to 278. According to Gale, you can't predict any of this by using the boost gauge. You need good manifold air density. Manifold air density rules and boost drools. Later in the build, at 18:1 air-fuel ratio and 5,000 RPM, the engine made 666 horsepower. At this point, the Duramax was also running 2 stock CP 3.3 fuel pumps, which Gale suggested he would upgrade to S&S pumps. Now, 666 horsepower was nothing to sneeze at, but remember, Gale was looking for twice that amount of horsepower. Next, the Supercharged Duramax got removed from dyno cell number 1 and got fitted with the next step in the engine's evolution: twin 6870 precision turbochargers and an intermediate liquid-cooled intercooler. Banks Power fabricated the liquid-cooled intercooler stage that has both a TurboSmart power gate 60mm wastegate to control the boost pressure within the intercooler itself, and a Big Bubba blow-off valve to vent boosted pressure to the atmosphere during shifts and drop throttle. This provided density-enriched boosted air that is force-fed to the supercharger inlet, and the dual TurboSmart wastegates keep the turbos from overspeeding. One important thing to note, according to Gale, is to not get hung up on shoving air and fuel into the engine. All of that has to also get out of the engine through exhaust. For the Duramax, Gale used a Banks Power exhaust manifold to allow more air out. If you don't scavenge the cylinders to the greatest extent possible, exhaust remains in the cylinders when the intake stroke begins, and that compromises everything you're doing with the compressor, the intercooler, the manifold, the intake ports, and the valve size. All that drive is restrained by the cylinder filled percentage. To remedy that, Gale used bigger exhaust valves, better flowing exhaust ports, better flowing exhaust manifold, and a set of headers feeding the turbochargers. The front of the 7.1 liter Duramax features 2 systems, the blower drive and the accessory drive. The blower drive is a timing belt system and a 2-to-1 overdrive, so when the engine is at 6,300 RPM, the blower is at 12,600 RPM. The accessory drive is powering the power steering pump, the 14mm fuel injection pump, and the alternator. These systems allow the engine to deliver instant throttle response and no slip, which was one of Gale's primary goals in this build. With this new setup recently finished, Gale estimated he would need 220 to 250 pounds of air per minute to make 1,400 horsepower. That air is flowing through 4 air filters feeding 4 MAF air sensors, which then flow into the precision twin turbo. Banks engineers are still working hard to get this supercharged twin turbo 7.1 liter Duramax completely dialed in, and once they get the final steps figured out, this engine should crank out the desired 1,400 horsepower at around 6,300 to 6,500 RPM for its intended use, the Diesel Brothers Brodozer monster truck. How awesome is that? Well, that does it for this episode of Diesel of the Week. A special thanks to our sponsor AMSOIL, and remember, if you have an engine that you'd like to see featured, please email me at gjones@babcox.com. Until next time, thanks for watching.